Empty space isn't actually empty. It's buzzing with an impossible amount of energy that could power our entire civilization. Today, we're exploring a brilliant thriller that blends cutting edge physics with science fiction in ways that challenge everything we think we know about reality.
You know what fascinates me most about the Z point? How it takes these mind bending quantum concepts and weaves them into this gripping mystery about a vanished aircraft.
Let me set the scene. We've got Tony Ishida, this brilliant cybersecurity expert investigating Flight 714's disappearance. While everyone else accepts the mechanical failure explanation, his pattern recognition skills lead him to something far stranger.
Right. Those thermal signatures that formed a perfect equilateral triangle. In a normal crash, you'd expect chaos, not precise geometry.
And this is where the science gets really interesting. The story introduces these things called exotic vacuum objects, or EVOs, which aren't just fictional constructs. They're based on actual research by physicist Ken Shoulders from the 1980s.
Hmm. So these EVOs, they're supposed to be self-organizing plasma structures that interact with the quantum vacuum itself? How does that connect to real physics?
Well, it ties directly into zero-point energy, a proven concept in quantum mechanics, showing that even in a perfect vacuum at absolute zero temperature, there's still this underlying energy present. The amount is theoretically enormous, enough to power our civilization for millennia if we could harness it.
The way the story connects this to electric universe theory is fascinating, suggesting electromagnetic forces might play a much bigger role in the cosmos than we currently think.
Exactly. And here's where it gets really interesting. The story proposes using EVOs to exceed something called the Schwinger limit, a theoretical point where empty space becomes unstable and starts creating particles spontaneously.
So that's how they explain what happened to Flight 714. It was caught in a failed government experiment trying to create stable wormholes?
Right. But what makes this story so compelling is how it builds on actual scientific research. The descriptions of plasma behavior and vacuum polarization aren't just made up. They're based on real experimental observations, even if the conclusions are speculative.
You know, it reminds me of how many breakthrough discoveries were initially dismissed as impossible. Like quantum entanglement, Einstein himself refused to believe it was real.
And that's the broader point the story makes. Sometimes revolutionary insights come from looking at dismissed or marginalized research. Tony's breakthrough comes from being willing to examine data that mainstream science had written off.
The technical accuracy balanced with narrative drive is remarkable. You actually learn about complex physics concepts while being thoroughly entertained.
Let me give you another example. The story's treatment of the quantum vacuum isn't just convenient plotting. It's based on real quantum field theory showing that empty space is actually a complex, dynamic system.
The implications are pretty mind blowing when you think about it, that what we consider nothing might actually be the key to unlimited clean energy.
Well, that's what makes this story so powerful. It takes real scientific concepts and pushes them to their logical, if speculative, conclusions. It challenges us to think beyond conventional frameworks while maintaining scientific rigor.
Looking at empty space differently really changes your whole perspective on reality, doesn't it?
That's exactly right. And perhaps the most important takeaway is how many potential breakthroughs might be hiding in plain sight, just waiting for someone to look at them from the right angle. The story reminds us that today's fringe science could be tomorrow's revolutionary discovery.